Okay. Fractional order indicates complex mechanism, elementary step, simple reaction, zero order, complex mechanism. For second order, half-life T half is 1 over Ka naught. Rate constant increases with increase in activation energy EA, decrease in activation energy EA, decrease in temperature none. Correct option is option B, decrease in activation energy. Chemical kinetics deals with heat change, rate of reaction, equilibrium constant, molecular mass. Correct option is option B, rate of reaction. The rate of reaction depends upon active mass only, temperature only, both concentration and temperature not. Correct option is option C, both concentration and temperature. Rate law expresses relationship between pressure and temperature, rate in concentration, rate in volume, volume in mass. Correct option is option B, rate in concentration. Order of reaction is sum of power of the concentration terms, molecularity, collision frequency, equilibrium value. Correct option is option A, sum of powers of concentration terms. Zero order reaction rate depends on concentration, temperature, catalyst, none. Unit of rate constant for zero order reaction is mole per liter per second. Arrhenius equation is option A, K equal to AE, E minus E over RT. Energy required to start a reaction is Bohr energy, lattice energy, activation energy, ionization energy. Correct option is option C, activation energy. Temperature effect on rate is described by Bantoff's equation, Arrhenius equation, Nord's equation, Einstein relation. Correct option is option B, Arrhenius equation. Molecularity applies to elementary reaction, complex reaction, reversible reaction, all reaction. Correct option is option A, elementary reactions. Molecularity is always fraction, whole number, 0, negative. Correct option is option B, whole number. Rate constant unit for first order reaction is per second. Catalyst increases rate by increasing temperature, lowering activation energy, increasing activation energy, increasing mass. Correct option is option B, lowering activation energy. Zero order reaction T half is A naught over 2K. Okay. Molecularity refers to number of reacting species in elementary step. Overall order, overall mechanism, catalyst, correct option is option A, number of reacting species in elementary step. A reaction cannot have molarity greater than 3, fractional negative 0. Correct option is BCD, fractional negative 0. Rate law determined by slowest step, fastest step, product step, none. Correct option is option A, slowest step. Catalyst affects mechanism, activation energy, rate, all. Correct option D, all. For first order reaction, rate constant K is independent of concentration, dependent on concentration, dependent on time, dependent on pressure. Correct option is option A, independent of concentration. First order integrated rate law, ln A equal to ln A naught minus KT. Rate K square represents second order. Unit of K for third order reaction is liter square per mole square per second. In a reaction, doubling A doubles rate order is 1. When A is double, rate also doubles. We know that rate proportional A over N. So let the initial concentration R at the concentration A. When the concentration becomes 2A, rate also becomes 2R. So 2A over N equal to 2A over N. So N equal to 1. So order is the A is to 1. So we can conclude when the rate change doubles, order 1, doubles change rate in quadruples 2, doubles no change 0 order, doubles triples fractional. In a reaction doubling the A increases rate 4 times, order is second. For 0 order, rate constant K independent of concentration, independent on concentration, depends on pressure, none. Correct option is option A, independent of concentration. Half-life formula for first order T half equal to 0.693 over K. For 0 order, T half A naught over 2K. Bimolecular reaction involves two reacting species, one species, three species, none. Correct option is two reacting species. In enzyme reaction, enzyme substrate complex theory is given by McCullough, Manton, Ernest, Dalton, Raoult. Correct option is option A, McCullough, Manton. Order of reaction depends on experiment, theory, gas, formula. Correct option is option A, experiment. Reaction with negative order indicates inhibition, activation, decomposition, none. Correct option is option A, inhibition. Enzyme catalyze highly specific, non-specific, random, irreversible. Correct option is option A, highly specific. Reaction with rate KAB is second order. Unimolecular reaction has molecularity 1. The first order plot ln A versus T gives straight line. Fractional order means complex mechanism. Reaction rate equal to K gives 0 order. Half-life of first order depends on K only. Reaction order, half-life expression, and depends on 0 order. We have A naught over 2K, both A naught and K. First order T half 0.693 over K, K only. Second order T half 1 over K, A naught, both A and K. Activation energy measured in kilojoule per mole. Order of radioactive decay first. In first order, 90% reaction time 2.303 over K log 10. Efficiency of catalyst depends on surface area, valency, weight, shape. The correct option is surface area. Catalyst poisons decrease activity, increase activity, no effect, start reaction. Correct option is option A, decrease activity. Examples of poisoning: lead on platinum, cobalt on iron, sulfur on nickel, all. Correct option is option D, all. Autocatalysis product: X is catalyst, reactant is catalyst, no catalyst, enzyme. Correct option is option A, product X is catalyst. Unit of rate constant depends on order, molecularity, mechanism, catalyst. Correct option is option A, order. Reaction coordinate represents progress of reaction, temperature, concentration, pressure. Correct option is option A, progress of reaction. Activated complex is highest energy state, lowest energy reactant product. Correct option is option A, highest energy state. Catalyst works by lowering activation energy, increasing activation energy, rising temperature, none. Correct option is option A, lowering activation energy. Temperature coefficient usually between 2 to 3, 1 to 2, 3 to 4, 5 to 10. Correct option is option A, 2 to 3. Heterogeneous catalyst examples: nickel is hydrogenation, enzyme action, acid catalyst, base catalyst. Correct option is option A, nickel in hydrogenation. Homogeneous catalysis example of hydride catalyst ester hydrolysis, nickel in hydrogen addition, ferrous in towers, platinum sulfur dioxide oxidation. Correct option is option A, hydride ion catalyze, acid ion catalyze, ester hydrolysis. Negative catalyst retards reaction, speeds reaction, stops reaction, none. Correct option is option A, retards reaction. In chain propagation, radicals react, radicals form, radicals terminate, none. Chain propagation, radicals react. Termination step, radicals destroyed, radicals form, radicals react, none. Termination step, radicals are destroyed. In first order, slope of ln A versus T minus K. First order reaction, the integrated rate equation ln A equal to ln A naught minus KT. The equation is in the form of straight line. So y equal to mx plus c. So y equal to ln A xt. So slope minus k. Order can be 0, fractional, negative, all. Option D, all. For 2A products, rates K square is second order. Temperature increase by 10 degree doubles rate. This is the temperature coefficient. Collision theory assumes molecules are hard spheres, point particles, warps, none. Option A, hard spheres. Collision theory proposed by Max Strauss and William Lewis explains how the reaction occurs based on the collision between the reactant molecules. The main assumptions of this theory is the molecules are treated as rigid, perfectly elastic, hard spheres. This means molecules are solid spherical particles. They collide like the billiard balls. Collisions are elastic, that is, no energy loss in the collision. Effective collision requires paper orientation, sufficient energy, both A and B, none. Correct option is option B, both A and B. Effective collision requires proper orientation and sufficient energy. High activation energy means slow reaction, fast reaction, equilibrium, none. High activation energy means slow reaction. Low activation energy means fast reaction, slow reaction, non-reaction, no reaction, none. Correct option is option A, fast reaction. Order determined by experiment, theory, assumption, ideality. Correct option is option A, experiment. Half-life of second order 1 over K A naught. For second order, plot 1 over A versus T straight line. Pseudo first order, one reactant is large, one reactant in large axis, equal reactants, zero order, none. Correct option is option A, one reactant in large axis. Examples of pseudo first order hydrolysis of hydrolysis of ester in excess water, hydrogenation, photolysis, none. Correct option is option A, hydrolysis of ester in excess water. Gas phase rate increases with pressure, volume, dilution, none. Correct option is option A, pressure. Frequency factor A indicates collision frequency, activation energy, equilibrium, none. Correct option is option A, collision frequency. Working catalyst remains unchanged in amount, consumed, decomposed, precipitate. Correct option is option A, remains unchanged in amount. Base catalyst condition, large surface area, small area, crystalline bulk, none. Correct option is option A, large surface area. Arrhenius plot, log K versus 1 over T, straight line. Chord, parabola, none. Correct option is option A, straight line. Slope of Arrhenius plot minus E over 2.303 R. Correct option is option A, minus E over 2.303 R. Increasing catalyst increases rate, decreases rate, equilibrium shifts, none. Correct option is option A, increases rate. Catalyst does not affect enthalpy, constant K, rate, mechanism. Correct option, option A, enthalpy. Enzyme reactions are biocatalytic, heterogeneous, chain reaction, none. Correct option, option A, biocatalytic. Maximum enzyme activity at optimum temperature, any temperature, 0 degree Celsius, 100 degree Celsius. Correct option is option A, optimum temperature. Enough enzyme graph falls due to denaturation, increased activation energy, energy release, none. Correct option, option A, denaturation. Catalyst activity decreases by poisoning, promoters, large surface, adsorption. Correct option is option A, poisoning. Catalytic decreases by poisoning. Promoters help increase catalytic activity, reduce activity, stop reaction, none. Correct option is option A, increase catalytic activity. Examples of promoter, molybdenum in iron catalyst, cobalt on iron catalyst, lead on platinum, sulfur on nickel. Promoter, correct option is option A, molybdenum in iron catalyst. Inhibition decreases rate, increases rate, non-reverse. Correct option is option A, decreases rate. Catalyst that stops the action, poison, promoter, inhibitor, both A and C. Catalyst stops the action, poison, and inhibitor. So correct option is option D, both A and C. Rate depends on concentration, temperature, catalyst, all. Option D, all. Order is sum of the powers in the rate law, sum of the stoichiometric coefficient, molecularity, none. Correct option is option A, sum of the powers in the rate law. Molecularity never fractional, negative, zero, all. Correct option, option D, all. Mechanism details from rate law, stoichiometry, mass, none. Correct option is option A, rate law. Reaction A plus B plus C gives product cannot be tall molecular, unimolecular, bimolecular, greater than 3. Option D, correct option. Option D, elementary, greater than 3. Photochemical coordination involves radicals, ions, molecules only. None. Correct option is option A, radicals. Chain termination step, radicals combine, radicals form, radicals break, none. Correct option is option A, radical combine. Chain initiation, radicals form, radicals destroyed, radicals stabilize, none. Correct option is option A, radicals form. Effective collision depends on orientation, energy, both A and B, none. Correct option is option C, both A and B. Transition state theory proposed by Oring, Ernest, Dalton, Raoult. Correct option is option A, Oring. Ernest constant A refers to frequency factor, rate of reaction, entropy, non-frequency factor. Reaction progress graph peaks, transition state, product, reactant, non. Correct option is option A, transition state. Catalyst lowers activation energy, enthalpy, use-free energy, non. Correct option is option A, activation energy. Zero order plots A versus T, straight line, curve, parabola, non. Straight line. First order plot log A versus T, straight line, curve, non, parabola, straight line. Second order plot 1 over A versus T, straight line, curve, non, parabola. Reaction mechanism, sequence of elementary steps, overall equation, stoichiometry only, non. Correct option A, sequence of elementary steps. Tau molecularity applies only to elementary steps, overall process, equilibrium, non. Correct option is option A, elementary steps. Activation energy measured from RNS plot, LNA plot, log P plot, non. Correct option A, RNS plot. Inhibitor lowers rate, increases rate, constant, non. Inhibitor, correct option A, lowers rate. In enzyme catalysis, substrate feels like lock in key, random, circle, non. Correct option is option A, lock in key. Denaturation affects enzyme activity, pH, pressure, non. Correct option A, enzyme activity. Reaction rate determining step controls overall rate, final product, reactant energy, non. Correct option is option A, overall rate. In complex reaction, order is experimental, theoretical, assume, non. Correct option is option A, experimental. Rate Ka over 0.5 is fractional order, integer order, zero order, molecule. Correct option is option A, fractional order. Photochemical reaction needs light, catalyst, inhibitor, non. Correct option is option A, light. Activation energy low means fast reaction, slow reaction, endothermic, non. Correct option is option A, fast reaction. High activation energy means slow, fast, constant, non. Correct option A, slow. Reversible reaction rate affected by catalyst rate only, both forward and backward rate, non. Correct option B, both forward and backward rate. Catalyst does not shift equilibrium position rate mechanism, non. Correct option A, equilibrium position. In heterogeneous catalysis, surface phenomenon, bulk, molecular, non. Correct option A, surface phenomenon. Adsorption mechanism used in hydrogenation, esterification, hydrolysis, non. Correct option A, hydrogenation. Poison decreases catalytic activity, temperature, mass, non. Correct option A, catalytic activity. Promoter increases catalytic activity, inhibition, enthalpy, non. Correct option A, catalytic activity. Log K versus 1 over T gives straight line, curve, non, parabola. Correct option is option A, straight line. Reaction coordinates diagram peak, activated complex, product, reactant, non. Correct option is option A, activated complex. First order slope minus K indicates rate constant, activation energy, collision, non. Rate constant. Pseudo order is used when order reactant, one reactant in excess, coal concentration, no reactant, none. One reactant in excess. A versus T straight line indicates zero order, first, the second order, third. A versus T. Straight line. Zero order. Enzyme action gives enzyme substrate complex. Enzyme action gives enzyme substrate complex, enzyme product complex, substrate product complex, none. Correct option is option A, enzyme substrate complex. Chain inhibition, radicals, coins, radicals increase, radicals constant, none. Correct option is option A, radicals, coins. Chain propagation, radicals maintain, radicals stops, non-inhibited. Chain propagation, radicals maintain. Half-life independent of initial concentration, first order, zero order, second order, fractional, first order. First order T half 0.69 over K. Rate proportional concentration, first order. Reaction with complex mechanism is order not equal to molecularity. For unimolecular decomposition, first order. For parallel reaction rate depends on sum of the individual rates, product, constant, none. Option A, sum of the individual rates. Mixed order shows fractional order, integral, unimolecular only, none. Correct option, option A, fractional order. Enzyme inhibitors reduce rate, increase rate, no change, none. Correct option, option A, reduce rate. Activation energy expressed in joule per mole. Rate constant increases with higher temperature. Log K versus 1 over T slope minus E over R. Diffusion control reaction very fast. Intermediate formed in multi-step reactions. Catalyst remains chemically unchanged, consumed, decomposed, none. Correct option, option A, chemically unchanged. Autocatalyst curve shows sigmoid S curve, straight line, parabola, none. Correct option A, sigmoid S curve. Chain carriers, radicals, ions, catalysts, none. Correct option, option A, radicals. Transit state formed at peak energy, minimum, constant, none. Peak energy. EA corresponds to energy difference between reactants in activated complex, product in reactant energy, catalyst in product, none. Correct option A, energy difference between reactants in activated complex. For second order, half-life proportional 1 over A naught. Rate law independent of stoichiometry, experiment, mechanism, none. EA lowers by catalyst decrease Newport. Catalyst adsorption on surface is chemisorption, physiorption, none. Possible in both A and B. Catalyst adsorption on surface is chemisorption, physiorption. Correct option D, possible in both A and B. Hydrogenation uses nickel, platinum catalyst. Enzyme optimum pH around 7. Inhibition constant shows inhibitor efficiency. Rate of decomposition of sodium pentoxide first order. Order determined from experimental rate data. Order equal to molecularity only in elementary steps. Okay, it's all about some MCQ related to chemistry. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That's now bye bye. See you again.